Okay, so here's another example question. So here I want my language L to be the set of all binary strings W, such that W is a palindrome. What's a palindrome? A palindrome is a string that's equal to its own reversal. That is to say, it's the same when read forwards and backwards. So here I've written out, part of the set. So here's a collection of palindromes, and if you see, if I pick any string in this set, read it forwards, 0, 1, 1, 0, and read it backwards, 0, 1, 1, 0, it's going to be the same. So we want to produce a grammar such that the language the grammar produces is the set of all binary palindromes. So have a go at that, and then we'll go through the solution in a moment. So as a hint, we notice that every palindrome, it starts and ends with the same character, and if you delete the first and last character, it still starts and ends with the same character. So we want to always ensure that the left and right symbols are made in matched pairs. So pause the video and have a go at that. Okay, I'm going to assume you had a go, so let's go through the solution together. So what can S be? Well, the empty string is certainly a palindrome, so I must include the case S goes to epsilon. What else? Well, strings of length 1, so I guess I have to include 0. I have to include 1. And then here's the magic trick. I want to ensure that the characters on the left and the right are made in matched pairs. So if I put a 1 on the left, I'd better also put a 1 on the right. And if I put a 0 on the left, I'd better also put a 0 on the right. So this is going to be the grammar for all palindromes. It's important you include the case for 0 and 1 separately. Suppose we left that out. So suppose we had S goes to epsilon, or 0s0, or 1s0, 1s1. It would be impossible for me to make a palindrome of even length. Because if I wanted to produce the string 0, 0, 0, 0, so S goes to 0, S0, I lied. It'd be impossible to make a string of odd length. So suppose it was 5 zeros. So 0, S0, and then 0, S0, and then I'm stuck. Because if I go up to epsilon, there'll only be 4 zeros. And if I add another transition like this, that'll be 6 zeros. So this will not work. This would be only generating palindromes of even length. I have to include the cases of 0 and 1 separately. So with that in mind, let's try and create a parse tree for 1, 0, 1, 0, 1. So S goes to match the first and last, 1, S1. Match the first and last, 0, S0. And then we've got a 1 by itself. 1, 0, 1, 0, 1. And there we go.